So let us start with a new very simple grammar to illustrate the ideas of an LR1 parser. And uh, so the grammar is a very simple grammar. Of course, it's a grammar very similar to arithmetic expressions. It is an ambiguous grammar. Don't worry about that. E is the only non-terminal, and there are a few terminals. Int is one terminal, plus is one terminal, opening parenthesis is a terminal, and closing parenthesis is the other terminal. So there are four terminals, one non-terminal in this grammar. And let us have a review of the parsing as such. So you see that parsing, the state of a parser table of the parser, the configuration of the parser, basically remembers the context in which we are operating. So let's say if this was my, if this was my input symbol, I mean input string, and if I am here, then I started with E. We have looked at int, we have looked at plus, and we have looked at this opening parenthesis. If we go through it, we'll find out that at that point of time when it points to int, the stack contains e plus opening parenthesis, that's the stack content, and the remaining part of the sentence or the string is all this part, int closing parenthesis plus opening parenthesis int closing parenthesis. So this is the end of the stack, and if I look at what are the possibilities, what are the possibilities of going ahead with finding the remaining part of the longest viable prefix. I will be finding out that there are quite a few options. One option could be this item. One option could be this item. The third one could be this item. So when I do not know what is there in my right hand side, because my parsing table was not constructed using any look ahead, in my parsing table I have seen this much, it's okay. But what is next? Where from can it be generated? There are many options. So there are many contexts which one DFA state describes. That's the first thing to understand. Now you see, so therefore if I look at it a little, if I just look at it the item in LR0, the term item just had a dot in between the RHS symbols. Here you see that the item has a very similar nature, has a very similar structure, but it contains a comma and then input symbol. It means that you have already seen the x you have already seen, and you are finding out that a is a terminal which is known as the look ahead terminal. So we are trying to find some x followed by a small a. But what we have on the stack right now, top of the stack contains some alpha. Beta is not there. And we think that maybe after this beta will be found out, then small a will be there. So my sentential form at the the right part of it would be beta and then a small a and the remaining part of the sentence. So what we have seen in the stack, whatever, but at the top of the stack I have already seen alpha. And what is that we need to know now? We need to know now what could be a prefix that can be derived from beta a. Not only a, beta a. Right? So we'll explain again about this. So let's continue. You see, this means that alpha is at the top of the stack, and gamma is a string of terminals that are remaining. So this LR1 item, in LR1 item, this dot is used to mark a prefix of the production RHS in this manner, where beta might contain non-terminals as well, and in both cases the stack is on the left. Now this A basically says that if I have seen alpha, and if I wish that I can see it through this, then this A says that maybe beta and the remaining part of the string beta and gamma may start with a small a, not gamma only. Beta and the gamma may start with a small a. Now uh, as before, we augmented the grammar with a with an additional dummy start symbol like is thus in the previous case. In this case, the start symbol is E, start non-terminal is E, and therefore we are creating a new non-terminal which is S, and we say that S is the new start symbol. And the initial parsing context says that after all, ultimately my grammar, my string should be seen from the new start non-terminal which is S, and then it will be followed by a dollar. So from S dollar, the entire input sentence and dollar can be found out, can be derived if the sentence is correct according to the grammar, else it will not be found out, right? So we are trying to find out an S as a string derived from E dollar, and to begin with, the stack is empty. So as I said, that assume that at some point of time your context says that mm, uh, we have already seen E plus at the top, and there is a plus here, and there is, I mean, what I need to do now. Now naturally, it follows that if this follows, then you can perform a shift operation, no doubt about that. And if I do a shift operation, then of course nothing much changes as the look ahead operator, because this is not to the because ultimately, I mean, I was expecting this thing followed by plus and followed by the remaining part of the string of the sentence. Now that does not change if I go over this dot. So ideally, therefore, when you do a shift on a terminal symbol of the grammar, then the look ahead does not change. Where the look ahead changes, we'll talk about it. Don't worry about that. I am not going to leave you without letting you understand that. However, if the context is the dot is here, what does that mean? That means the handle is found. That means that the handle is found. Not only that, it basically means that I need to reduce. I need to use a rule to reduce this handle, to prune this handle. But this plus says that you can perform a reduction only when this plus follows. This plus is at the input symbol, only then you can actually do a reduction. Again, all this will be amply clear as you go ahead, and we'll talk about uh, the thing. So let us go to the example, as I said. So construct the start context. What is the start context? The new start symbol produces dot e and dollar, right? Very fine. Now again, as previously, dot precedes a non-terminal. Therefore, all the rules in which e appears as at the left must be counted in. So there are two rules with e, and dot e plus the remaining part of the RHS, and naturally dollar does not change now. E produces dot in, dollar does not change now. But now look at this rule. Look at this rule. Just look at this rule. Here, this dot precedes this e, right? So again, I have to write this item again. What for? Of course, if you don't look at the right, I mean the second component of the item, this item and this item are the same. They are different. They are different only by their look ahead symbol. So how did I look? How did I say that? I said that if we use somehow this rule, then the remaining part of the of your sentential form should begin with a plus. Why? If you take this part, then after this e, a plus opening bracket capital E, small opening closing bracket will come, and followed by your dollar. So therefore, now this says this is the same item. However, the look ahead changes. Similarly, because this E can give rise to two different items, both of them were already there with different look ahead items. Another look ahead item comes here. Another look ahead item comes here. So this closure is very interesting. The closure says if I go to a new, if I create a new item, maybe the look ahead character may change, may increase. Now you see that the same item first component has two different second components. So we abbreviate as the first component remains the same. However, the second component could be a dollar or could be a plus. Similarly, the this int e produces dot int, the first component remains the same. The second component may be either a plus or a dollar. Just a minute. There are two ways to look at it. One is algorithmic way to construct it. Another is the semantics of it, the logical meaning of it. I will try to tell you both of the ways. One is if I have ever dot preceding a non-terminal, then all rules for that particular non-terminal must be included here. So the first component of the item is very simple. What about the second component? If you are using this rule to add more items, then this is the non-terminal and this is your beta. The whole part is your beta. This beta and this small a, whatever is the first, remember the first set in LL1 parsing, the first set of beta a, all the elements which are there in the first set of beta a will be added for that item here. Now, what is this beta? That this beta starts with plus. Therefore, if something starts with a terminal symbol, its first can only be that particular terminal symbol, nothing else. That is the algorithmic part of it. And what is the logical semantics part of it? We said that the context was E. Here also the context is E, but here the look ahead changes. So this change in the look ahead I must incorporate for the rules for E as well. You said that, I can see int and the look ahead is dollar. Now I understand that this int can be found out from this E as well. From this E also this int can be found out. And if this E was used to find out this int, then this plus will be the look ahead, not this dollar. I do not know which one is actual look ahead. So therefore I write maybe the look ahead is plus, maybe the look ahead is dollar. In both cases, these items are okay. Correct? So this is the new small piece of information that I incorporate here by considering one look ahead terminal, one look ahead symbol. Now understand that the algorithm, the parser driver, the parser program does not do any look ahead. While constructing the parsing table, while constructing the DFA, we are actually creating this, considering this look ahead. Very interesting. Many people think that look ahead means the algorithm looks ahead and sees what is there in the input string. No, the parser table or the DFA is constructed by considering a look ahead. While in LR0, it was never considered. What could be the look ahead? Nobody considered. So therefore, the second component was missing there. The second component comes here just because we understand that it is important, and we will consider just one look ahead, and therefore we'll see only one symbol here at a time, not two symbols. This is one symbol at a time, not this is not two symbols at a time. I could see two symbols. I could see two symbols and create another parsing table that could be LR2 parsing table, right? So the semantics is this. Now a bit of very small theory. So if I want to construct the DFA for an LR1 parser, it is a closed set of LR1 items. Now what is meant by closure? We have already talked about it. Will be more detailed later on. So the start state contains this particular item. The closure of this particular item. Now a state that contains this much is labeled with reduce with this particular rule on B, nothing else. So follow set, which was very important in SLR parsing, has lost its importance now. Follow set is no longer used in LR1 parsing. However, first is used. And then comes the transitions. So the transitions are this. If I have alpha dot y beta, if I have this, then I add this particular alpha y dot beta. See, the look ahead does not change by that. Look ahead does not change by that. And then I close close this item. And if I do, the moment I close it, I get a go to set. Now, what does closure means? Remember, I told you repeatedly. I I I mean, if I have a dot preceding a non-terminal, then I need to consider all productions where this non-terminal is at the left. So, and then I have to add the first component without any fail. But what will be the second component? The second component may or may not remain this small a. The second component will remain this small a if this beta is not there, or if this beta can produce epsilon as well. Basically, this B are all those terminal symbols which appear in the set first of beta A, not gamma, beta A, because you are assuming that you will be seeing this alpha, and then what could be the next thing? What could be the next thing? I mean, after all, everything will be reduced to y. Then beta will be remaining there. So, what is the first symbol that you can see in beta? What is the first terminal symbol that you can see from beta A? That is the question, right? So, this is the closure. The adding the second symbol is tricky, and adding the second symbol is adding from here, not from here. This is the most crucial thing that you need to understand, right? Okay. So let us do a thorough exercise which you also did in the case of LR0 parser. So let us say that this is my step number 0, which you already have talked about. Now from here, what could be the go-tos? What could be the go-tos? Think about it. Of course, one go-to could be int, the other go-to could be capital E. Why? This dot precedes only these two symbols. So see, yes, it can be an int or it can be an E. So if it is an int, it goes to maybe I1. So what is that I1 then? I go across this dot, right? So this dot now does not precede anything. So whatever was the look ahead, they remain as the look ahead. What about this E, right? So what is the action? The action is reduced using this rule. But when? If the input symbol is plus or if the input symbol is dollar. If the input symbol is opening parenthesis, if the input symbol is closing parenthesis, no, you will not do that. What about this E? I go across this E dollar, no problem. This says reduce when the input symbol is dollar. Otherwise, I do this, and again this dot precedes terminal symbol, so nothing more to add. So, I mean the action here, I mean shift actions, I mean except on dollar, that's the one. The shift actions are not shown. Now, what are the go-tos now? Only plus, because dot precedes only one symbol, and that is a plus. So when it goes there, as I said, it goes across plus. So so this does not change. Now from here, it can visit. I mean, it can go past a it can go past a opening parenthesis. So let's see. The moment it goes past opening parenthesis, I see that two rules come in, and the look ahead changes. How does this look ahead changes? I mean, you see this E, this is the item, no problem about this item. Now, what is beta now? What is beta now? If I do this, what is beta now? Beta is closing parenthesis. What is A now? Could be dollar, could be plus, right? So could be dollar, could be plus. So what is the first of beta A? What is the first of beta A? First of beta A will be the closing parenthesis, correct? Right? And similarly here, E produces int, but this one is the beta. So with this beta, we can have the closing parenthesis as the we add that as the I mean as the look ahead there. So we add that and dollar no longer remains there. Correct? So if I may ask you a question, how come plus remains here? Can anybody try to answer that? It is the same thing as happened. Like we see with the dot, this dot, the beta is opening parenthesis. Sorry, closing parenthesis. With this dot, my beta starts with a plus. So opening parenthesis comes from this item. Plus comes from when I write it again from because this dot precedes the C, again the same item comes back. The first part remains the same, but the second part, the beta is different. Beta starts with a plus, and therefore this plus comes here. This is very tricky. This is very crucial. You must understand this part very well. If not, you can easily chat with me. You can ask me in classroom. You can ask me in YouTube, and I will be happy to answer that question for you. So now here again, I can jump on an int and I can jump on an e because dot precedes int and jump. Now these two jump does not change my situation at all. Also see state number 1 and state number 5. If you are at 5 and then your input symbol is this one, then you have this reduction. But if you are in state 1 and you have input symbol as closing parenthesis, you cannot use this reduction. So when to reduce is very clearly answered. Look at these symbols, look at these look ahead symbols. On those symbols, you can reduce, not on anything else. That's what I'm saying. Similarly here, I mean again, I mean since this is E, I get I jump here. The moment I jump here, I come to here, and again after this I come to here. So dot, no, the moment dot visits on terminals, we do not uh, need to increase or add any other item to get a closure. So this is the way it will continue to go on, and the number of states will definitely be larger than the LR0 or SLR way of constructing the DFA. Nonetheless, we are not going to do it. As I always tell you, whoever will be doing it is a program. So that does not make a difference to us that how many states are there and all. We need to understand it. We need to be able to write the program for this LR1 parser, and that will be all for us. So I believe that the example is done, the parsing technique is done, and I must conclude with by saying why I went there. Again, I go to the first grammar that I started with, and I have to show you that the simple LR0 way of constructing the set of states. I0 would be all dots here, because this dot L will induce this dot star, this dot id, this r, this dot r will induce this r dot l. Now once from I2 I go on the non-terminal L, I reach I1 from this I0. If I go to the state on the non-terminal L, I come here, right? And I see that follow of R contains equality symbol. Then what is wrong in it? Of course, equality may follow R, but yes, equality may follow R, but there cannot be any viable prefix with just R equal to. The viable prefix has to be star R equal to. That piece of information was missing in this LR0 parsing table or SLR parsing table. See, anything and everything that can follow may not be applicable in a particular viable prefix. Something may follow means it follows in some viable prefix. not in every variable prefix. This equality symbol follows R, no doubt about it. But there is no variable prefix which is just R. Then the variable prefix has to be star R. So this small difference cannot be captured by this SLR parser. And that can be captured by the LR1 parser. How? Let us have a look at it. See the second component. This is the first dollar. So again, these two dollar will come automatically. It is very easy to see. Now, when this L dot B dot precedes this L, then L produces dot star R, right? Dot star R. Now, why this equality then? I came from this, I use this dot to get this item. What is the beta? This beta starts with equality and R. And therefore, equality R and dollar taken together, first of that would be equality. Then again you may ask me, how come this dollar? The same question, same answer for that. The same answer for that. Go back and find out. There are two ways to get this particular item. One item tells you that this could be a look ahead. The other item tells you that this could be a look ahead. This is the trickiest part in LR1 parsing. Anyway, that is not the concern as of now. I have discussed about it in previous two, three instances, so that is okay. So you see that if I do a jump on L from I0, I go to I0, then I go to I2. Now what is I2? I2 is simple. S produces L dot equal to R. Dollar does not change, no question. R produces L dot dollar. Meaning, if you ever come, it is a reduction, but it says reduce only when the input symbol is a dollar. Otherwise, do not do that. Now then, when R equal to comes, yes, that's the question. See, if I move from I0 using a star, where do I go? I go to I0, I4. So I come to I4 again. This is star dot R, right? The moment you start dot R, I have to add items per closer. So R produces dot L. See, nothing changes because after R, no beta is there. Beta is absent. So these A's come as they are. Now, since L has again come, then the items for L are to be included as well, right? And from I4, if you get an L, you come to I8. So see, this reduction and this reduction are the same. But if you are in I8 and get the reduction, then the variable prefix is star R equal to. Star, yeah, star L equal to, and you are changing it to R, which basically after changing becomes star R equal to. It is star L equal to. That's how you reached. That's how you reached I8, and if you replace L by R, it becomes star R equal to. And star R equal to is a very much valid variable prefix. And that's how, if you reduce this in the state number 8, that's correct. But if you reduce in state number 2, that's not correct. Follow is not helping. My look ahead is helping me to the greatest extent. So, just summarizing, SLR is too simple. LR1 parsing uses look ahead to avoid unnecessary conflicts. So LR1 item is equal to LR0 item plus a look ahead. And this is what the basic closure operation is. We talked about it. If A produces alpha dot B beta comma A, if I have this in a set, then its closure will contain all rules of the form B produces gamma, and the second component will be all the small b's which are available in first of beta A, not gamma A, just beta A. And you have to repeat it unless new items can be added to that particular thing. And in GoTo, the look ahead does not change. That's all. The construction of the LR1 items of grammar you can read it. We have explained it with the example, and that's exactly what we will do. So so the remaining part is this, and we may start from here in our next class when we'll talk about LA LR parser as well. So thank you very much for your attention. If you have any questions, come to me, go to classroom, ask your questions, or you simply um, uh, put the question in the YouTube comment section. I will answer to that question. Thank you very much. Have a very good day.